Good morning. My name is Ian Norton. I work for Philips Healthcare. I'm a medical physicist, and I've been working in radiation oncology for 20 years now. Prior to working for Philips, I worked at the University Hospital in Zurich, Switzerland. I originally come from Canada, and I did my original training at Princess Margaret Hospital. Today I'd like to talk about Pinnacle. In Pinnacle, we have a new release of the software. It's Pinnacle version 16, and I'll focus on automatic and adaptive planning for radiation therapy. In Pinnacle version 16, we have quite a lot of new enhancements. There's a new look and feel in the software. The windows are fully scalable. We can scale the images to full screen. There's contouring, image fusion, image deformation, 3D conformal, IMRT, and VMAT, and adaptive planning in the single user interface. So there's quite a bit of time savings that the user will experience with contouring using model-based segmentation and also auto-contouring with SPICE. We also have very fast, high-quality, machine parameter-based IMRT and VMAT optimization in Pinnacle. And on top of that, we also have auto-planning options in Pinnacle. So Pinnacle has quite a lot of it for the user to experience. It's very powerful software. In the new user interface, this is an example of what it will look like, for example, when you're contouring in the software, so you can really make use of the full screen while contouring, and you can really fill the screen with really the images you're working on. This is an example of an MR image, so you can really focus on the area that you want to contour in the software. A major feature of the new software is what's called dynamic planning. This is the adaptive and replanning suite within Pinnacle 16. So the deformable image registration, the DIR algorithms are used to deform dose, scale dose, adapt the plan, and also to accumulate deformed and adapted dose. There are enhancements to the DIR algorithms, greater user control over the DIR algorithms as well, and we have specific algorithms for CT, CBCT, so cone beam CT algorithms. We also have quality assurance tools, QA tools, and we can scale and deform previous dose using DIR, also import dose from other systems, and deform it as well, and accumulate that dose on the newly calculated data set. The dynamic planning options, or adaptive planning options in Pinnacle, are designed to address two major clinical problems. One is adaptive planning. So we work with the delivered dose for the plan, the patient changes, and we want to deform that original dose to the new data set. So we can do that and sum or accumulate that dose onto the new data set. We can do that multiple times. Also, because patients are living longer and they come back to many clinics for retreatment, we can also use this software for that as well. So we're seeing in many clinics, patients are cancer survivors who come back and get treated again. So the original plan dose is deformed and added with a newly generated treatment plan. The technology behind the deformable image registration is multi-threaded fast symmetric daemons. I know it's a lot to say. Basically there's improvements in the daemons algorithm for extended capture range. So in order to do the deformation, for each voxel in the data set, it needs to search for a more appropriate voxel in the new data set, and it has basically more possibilities to find a more appropriate voxel. So that includes an extended capture range, There's improved accuracy, so additional algorithms, for example, to make cleaner contours, and also specific settings for cone beam CT. There's also additional user control settings, so the user can limit, when they wish, where the deformation will happen in the data sets. So if you only want the deformation to be in a certain specific part of the data set, you can set that as well in the software. And there's algorithm parameters for controlling different settings. So basically, how elastic the deformation needs to be. There's also automatic workflow possibilities to allow for intelligent automation. And we've had this in the software previously, but we've really worked on this so that in the vast majority of cases, you don't need to do all of this work. You can just run it through the automatic functions in the software, and it will adapt the regions of interest and the dose automatically. Here's an example, a very simple example right here, where the patient originally has quite a large tumor on their right side, and into the second week of treatment, this tumor has responded quite dramatically. It's shrunk quite a bit. And we can visualize that deformation, the way that the deformation algorithm has shrunk that original data set to fit into the new data set through deformation vectors. And we can also do quality assurance. So this is an example of the QA tools window here, where we can do an analysis of the deformed ROI with the original region of interest ROI. Again, if we do comparisons on the ROIs themselves, if you look at where the arrows are in this data set, this is an example here, you can see in these different areas here and here, they match very closely to the original region of interest. We've done this with many, many data sets across many test centers. Here's an example for dose. So due to patient weight loss, there was poor target coverage, and that's illustrated with the dashed lines here. Okay, the solid lines are the original dose. So here, for example, for this risk organ, the dose increased quite significantly. We would want to adapt the plan. And we can also scale the plan, scale the dose when we accumulate this adapted dose as well. We can change the number of fractions, and we can also use a scaling factor. So a scaling factor is very important when you have prior treatments, previously treated patients. Here's the example after the plan is re-optimized for the patient change. So you can see right now that, in fact, the dashed line here is representing the adapted plan, and it's even better for some of the risk organs than the original plan. This can happen. And here's an illustrated example of the dose. So this is the original dose planned on the original data set, and this is the accumulated original and deformed dose. This is very easy to do in the software. In summary, Pinnacle 16 is now clinically released. It's installed in a number of clinics in the United States and in Europe. It features enhanced deformation algorithms with powerful user control, powerful dose accumulation options using deformed and rigid. You can also accumulate rigid dose with scaling options. And this is all combined into the new user interface with improvements to help with user interactions and plan generation. The result, of course, is a robust deformable registration solution with QA tools, quality assurance tools, to support important clinical use cases for adaptive planning, replanning, and also patient delineation, patient contouring. Great. If I'm allowed, I don't know, how much time do I have left?
You could sometimes.
A little bit of time? Okay. So I'll talk a little bit about auto planning in Pinnacle, because many people ask me about this. Auto planning is automatic IMRT and VMAT planning. So in this kind of planning, it's not like the traditional IMRT planning. We actually work with the clinical goals. Okay? Sounds obvious that IMRT should be working like this, but in most cases what people put into the software to get to the clinical goals is not the clinical goals themselves. They put some other kinds of goals into the software. They also may have to generate quite a bit of manual data, so we replace that. It's all done automatically. The whole point is to enhance plan quality and consistency. Also, for auto planning does not require a library of plans. It's a big difference. And it's fully algorithm based. It's very powerful software, and I can say that in every clinic where we have this installed and working, the people love it, well, without exception. Basically, the work is done in generating what's called a treatment technique. This gets loaded, and then auto planning is run, and you can evaluate the plan at the end. You can also continue to optimize the plan if you wish, or you can run it another time with different clinical settings. It's very simple to use. The algorithm behind auto planning is called progressive optimization. It mimics the experienced planner. It generates regions of interest to shape the dose, works with the clinical goals to achieve the correct dose to the patient. Sparing risk organs, adding OAR objectives, region of interest objectives, adding hot spot and cold spot objectives, fine-tuning each objective, and running the optimizer multiple times. So it's very iterative. So really, auto planning pushes to get a very sharp and uniform target dose coverage, and is always pushing to spare OARs. This is a list of the major centers that we developed auto planning with, and I can't share the list of centers that have auto planning right now. The list is too long. It's huge. It's nearly 300 centers worldwide. It's an example of auto planning in a pelvic case, really truly based only on the clinical goals, a very small list of clinical goals. No user added structures were added for optimizing this plan. Again, for a head and neck case, and I have much more complex cases than this that auto planning has done, multiple PTVs are supported, so multiple targets are supported in auto planning. And you can really see that the isodose lines conform closely to the targets, and the user has much control about how tight they're allowed to conform to the target and how much risk organ sparing is desired. This is an example of a scorecard in Pinnacle where we really have the clinical goals in the scorecard, and in many cases you'll just see met. It's very, very powerful software.
Скажите, пожалуйста, применяется ли ваша программа и программное обеспечение в каком-нибудь из медицинских центров в России?
We have Pinnacle installed in a number of clinics in Russia, in Moscow and Novosibirsk, for example. I know of a number of centers, but the newest version of the software, this version right now, is just being released now worldwide. So when we start with a new version of software such as this, we do an initial release that's limited, and we monitor it closely. And we are at the end of this phase, and we are just starting with the general rollout, general release. So I expect it to come to Moscow very soon, or to Russia very soon.